Hey guys, today I wanted to talk to you all about del, the handy dandy partial derivative operator. So what exactly is del? Del is just our collection of partial derivatives with respect to x and y and z. We can do a lot of cool things with del, like find the gradient, which is going to produce a vector field from a scalar field. It's going to point in the direction of the max rate of change. So here, literally, we're just taking the gradient of a function to be the partial derivatives of that function with respect to the different variables x, y, and z in those particular directions. So let's take a scalar field. You might be saying, Mr. Shack, why is there no z here? Well, we're going to make it easy for us to visualize. If we take this function f, find the partial derivative with respect to x and with respect to y, that's going to give us the vector field in those directions. Here you can see our nice flowing scalar field. If we turn on the gradient here, notice how we're pointing down the hill. Hey, it's flat right there, so there's no gradient. Here we're pointing down this hill. If I slide over, notice I can see that the gradient is literally just flowing down this hill. I could keep on sliding over here, and notice it's the same thing that we had over here. I can see exactly how my gradient of my system is going to work. We can also use del to find the curl of a function. This is going to be the vector product, and it's going to show us the magnitude and axis of max rotation of our vector field. Obviously a little bit messy here, but if you recall, we took our scalar field, turned it into a gradient. That vector field, well, everything in the z direction, it just goes away. And if we take the partial derivatives that we need here, we see they actually cancel out. Our curl of our gradient field is 0.